In today's video, we'll be taking a look at AC sine waves, how they are generated and the components that make up the waves. Alternating current, or AC current, is a current that reverses its polarity between two set values in a certain time period. You may be familiar as this is the regular household current that we use every day. AC power is generated through an energy source, turning a rotor inside a set of windings housed in the stator. As the rotor turns, its polarity reverses every half turn due to the magnetic poles, creating an alternating current. An example can be seen on the right-hand side. Some sources that create this sort of current is nuclear fusion, water power, and air turbines. The waveform of a sine wave is the path travelled by a quantity. It is a representation of how alternating current varies with time. As can be seen on the right, at the top, the most common being the sine of the elapsed time, but as it can also be seen, there are other types that also can be used. The instantaneous value of a sine wave is the magnitude of a waveform at any instant of time. On the right hand side, the small arrows inside of the sine wave are a good representation of these values, and usually denoted by a lowercase e. The peak amplitude of a sine wave is the maximum value of the waveform as measured from its average value. On the right hand side, it is the peak of the sine wave. The peak-to-peak value is similar to the peak amplitude, however it is double its value, as it's the full voltage value between the positive and negative poles of the waveform. It is denoted by an uppercase E or V. The angular velocity of a wave can be derived from the length of the vertical projection of a radius vector rotating in a uniform circular motion about a fixed point. The velocity with which the radius vector rotates about the centre, called the angular velocity, can be determined from the following equation. The general format or equation of a sine wave can be seen below. A sine omega t plus or minus phi. A is denoted as the amplitude of the wave, or the voltage. Omega is the frequency. And on the left hand side, some formulas can be seen to calculate the frequency of a sine wave. T is the time in seconds, and phi is the phase angle. If it is positive, that means that it is shifted to the left. If it is negative, it means it is shifted to the right. Thank you for watching this video.